Okay, next let's speak about our storm control, not a layer 2 feature. So what is storm control? Which again, by the name, it's a feature scoped to control traffic storms. So it's going to prevent network down situation because of excessive unicast, multicast, or broadcast traffic. What that means is very simple. It's a lot of use case. It's a lot of course, possible situations when problems can appear. But it's very simple. If, for example, I have this design. This PC has an address of 100, router 1 has an address of .1. And this guy in the middle is just a layer 2 switch. If we go on switch 1 and we say show MAC address table, static, it says that for all VLANs, traffic, it says in here, there we go, traffic with a MAC address of FFFA, which is a broadcast traffic. Doesn't matter on which VLANs that's being received, it's going to get punted to the CPU. And that makes sense. Because broadcast traffic in a valid, let's say in a functional, workable, and legitimate IP network, broadcast traffic is rarely seen, but is useful. It's needed, for example, for ARP traffic and pretty much for DHCP traffic, so it is needed. So what happens is that when the switch receives a packet destined to FFF, not only is going to forward it out on all ports, it's going to also be interpreted by the CPU. So when PCA sends a broadcast ARP request, not only switch 1 forwards that packet because it's broadcast out on all ports in that VLAN, but also punts it to the CPU, which means it's going to be likewise process switch to see, the switch wants to see, oh, maybe somebody asks about me, maybe somebody needs my services, whatever those are. And by the way, nobody replied to me to the question that why does a switch, when a switch receives a packet with a DMAC of FFFF, which is the broadcast MAC address in Ethernet, why does it send it out on all ports? Why is that? Now let's continue. So because that broadcast message is also interpreted by the CPU of the switch, again, remember that what you have to understand is that even a very high platform which can forward hundreds or thousands of terabits per second, that platform doesn't have that capabilities in process switching in a CPU, but in the hardware, in the ASICs. So even that platform, if you hit the CPU with maybe a couple of megs per second, depends of course on the platform, could be 1, 2, 5, 10 megs per second of broadcast, you're gonna go high, you're gonna make the CPU go, the CPU is gonna go 100%, and at that point either the device is going to crash, or it is going to not have enough resources CPU wise to process real control plane packets, which means control plane is broken, data plane is broken. So of course, imagine that this is actually a bigger network where this switch one, maybe this is our core switch, for example. It's our core switch in there, and somebody connects to the core switch, this PC, for whatever reason, just to manage the core switch for whatever reason, to do some testing. And even either is going to be actually, this PC is going to be an attacker, or it has some malware installed on the PC and is not aware of. But the end result is that PCA is going to send, for example, like 1 or 2 megs per second of broadcast traffic. which because this broadcast traffic, not only the switch is going to forward out on all ports, but it's going to be also punted to the CPU, that broadcast traffic. As it gets punted to the CPU, it is going to cause the CPU to go close to 100%, where the switch can either is going to reboot, or it's not going to have enough time to process other control plane packets, like routing control plane packets, or VTP packets, or STP packets, which could create chaos in the network. And there are, of course, other use cases in there. And that chaos can be, let's say, that network chaos can be reached, unfortunately, with both excessive unicast or multicast or broadcast traffic. Now, Storm Control is pretty much aimed to fix that problem. It's configured per layer 2 port. It's a layer 2 feature. It limits ingress traffic on that port based on either bits per second or packets per second. Now, before I continue, just to make sure that you don't go tomorrow in production network and configure this feature, you have to always, before you configure something, you have to always make sure that on the platform you're going to do it is going to behave as appropriate. Because Storm Control, if you configure Storm Control of type broadcast or multicast, depending on the switch model and line card, if it's modular, Storm Control can actually filter BPDU packets, because BPDU packets are destined to a multicast address. So you can imagine that you don't want that accidentally, by putting Storm Control, to drop control plane BPDU packets, which means you open yourself to a big loop in there. Okay. Now what is Storm Control? So we saw what it is. It's a layer 2 feature aimed to limit inbound traffic of type unicast or multicast or broadcast at a rate of bits per second or packets per second to avoid network meltdown or CPU overload of network devices. Now, if configure policy is violated, which means inbound traffic exceeds the configure limit, what happens by default is that exceeding traffic is dropped. That's what you would want to happen, and a syslog message is generated. Now, optionally, we can configure additional violation actions in there, which can be auto SNMP trap generation. Maybe you don't have a syslog server, so it means that if the switch just log a message at the console, nobody knows about it. Maybe you actually use to monitor the network as an SNMP station. So in that case, you would want Storm Control, if a violation of the policy happens, to send an SNMP trap. Or if you want to be more aggressive, you just put a port in the area disabled state. So if violation occurs, you just shut down the port logically, put it into area disabled state. And of course, to recover from the area disabled state is like any other area disabled recovery method, either manual shut, no shut, or you configure the area disabled recovery feature for Storm Control. Now, configuration wise, it's simple to just enable Storm Control at the port level. You specify for which traffic type, unicast, broadcast, multicast, or all of them. And for each of the traffic type, you specify the traffic limit that switch allows inbound on that layer 2 port. And of course, optionally configure additional violation actions, which is an SNMP trap or shutdown. Which shutdown means area disabled. Verification wise, you verify Storm Control configuration, which shows Storm Control unicast or multicast or broadcast, or show Storm Control with the interface number. Now, depending on the platform you run onto, not both of those commands may show you the proper output. Both of them are going to work, but it may happen that you're not going to see the proper output if you use one or the other. So it depends on the platform. Now, configuration wise, so let's go on this port in here and enable Storm Control. Actually, no, let's go on this type. It's going to be easier for me to flood a network from router 1. Let's go on this port facing router 1, and put storm control, let's say for unicast packets. And then what I'm going to do is I'm going to go on router 1 and flood the network with unicast packets in order to reach the configure storm control limit and for traffic to be filtered and for a log message to be generated. So let's go on switch 1 and let's say show run interface FA101, that port facing router 1, and we say storm control. The command is very obvious. For which type of track do you want to configure limit? I'm going to say unicast in my case. Level, let's say in packets per second. And how many packets per second? I want to say not more than 2 packets per second. The rising threshold, actually, because it's packets per second, it's going to be exactly 2 packets per second. If you say now show storm control unicast, it tells you that on port FA101 the current filter state is forwarding because I have not exceeded the limit, where the limit is 2 packets per second and currently is 0 packets per second coming in. If you say show storm control interface FA101, so show storm control, as I said, it pretty much doesn't show you. So this is, you might believe that storm control is not active, which actually it is. If we say the traffic type, it shows up again. So make sure this command works, but not on all platforms, unfortunately. The show storm control fast 101. So now let's go on router 1 and flood the network. I'm going to go on router 1 and ping PCA unicast packets to flood the network. Ping. There we go. And it says the unicast storm detector a packet filter of action has been applied on the interface. Let's go on router 1 and say ping that and repeat 1000. And there we go. Some packets are being dropped as I'm reaching the limit. So I have intermittent access because some packets are being dropped. And of course, each time the router generates a log message. A packet filter has been action has been applied on the interface. If you say show storm control unicast, current is being blocking, as you can see. Then it's forwarding again. Then it's blocking again. So router 1, as we can see, we have intermittent access back and forth. Of course, you can go on the, as I said, on the switch, and as addition to the syslog message being generated, you can either say SNMP, you can add additional action, storm control action. So this is going to be an additional action to the syslog message. It's not going to replace syslog message because it's not configurable. It makes sense. So if you could replace the syslog message being generated with something else, it means you would have in here the syslog message option, which is not there, which means that's a built-in violation action, and you can additionally add one more action, SNMP trap or shutdown. So let's say shutdown. So now let's ping again, let's start again, and now a log should be generated, and also the port should be error disabled. And pretty much at this point, there you go, link went down. So switch has said that storm control error detected, put in the port in error disabled, and the packet says that a shutdown action was done in there. So this is the error disabled message. This is the fact that the port was actually shut down in there. So if you say show interface status error disabled, as you can see, interface FH101 is in error disabled state because of the storm control configuration in there. And of course, if you want the port to be still recovered, we're going to say error disabled recovery cause storm control, and error disabled recovery interval, let's say 30 seconds. Of course, let's stop the pinging process from router 1, which is gonna cause a violation again. And now if you say show error disabled recovery, it's gonna recover this port in 6 seconds. So 24 seconds have passed. It's 6 more seconds gonna recover the port, and of course, attempting to recover, it's gonna verify if violation is still there, and it's not, and port is up and running again. There's a question from Matthew. Isn't that very CPU intensive to generate those logs? So you can either configure logging filtering. You can do that. We can configure logging rate limiting, or of course, in general, in most production networks, what people do, they put the shutdown action, because that's what I want, clearly. Because if I leave the attacker send enough traffic in a network, even intermittently, it could actually cause problems in the network. So in most cases, what most companies are doing is that they're going to put the shutdown action in there. So once you are going to exceed that limit, the port goes into your disabled state. It is what it is. And of course, in general, pretty much, if you want high security, you also are not going to enable the error disabled recovery for that problem, because at that point it's like you automatically put the attacker back in the network after 30 seconds. So you don't want that. Piyush says unicast traffic hits the CPU. No, of course, unicast traffic hits the CPU only if the destination MAC and destination IP belong to the switch. So if PCA sends a unicast packet source from PCA destined to router 1, this traffic is never ever, because this is IP header, this is the IP header, and the MAC header, the layer 2 header, is going to be clearly a source of likewise PCA destination of router 1. So this traffic, when switch 1 receives this traffic is never ever going to hit the CPU. So only broadcast traffic or multicast traffic can hit the CPU of a network device in there. The broadcast traffic always, multicast, it depends on the network, on the device type, and on the configuration. But unicast traffic can also cause chaos in the network, because this is what is called the microflow attack. If this router is infected and it sends at a very fast rate unicast traffic, but a lot of unicast traffic, so unicast traffic with different destinations, destination X, or the same destination, doesn't matter, destination A, destination B, somewhere in the network, or network device which has to actually forward those packets. One device in there, it can happen that it's not going to sustain that number of flows per second to create. So that's a microflow attack. You could have a device in the network which cannot sustain. It's not a problem with the throughput, it's not a problem with what is the volume of the traffic, but it's a problem with how many sessions do I have to build in there. So if that device is likewise a network device somewhere in the core, and that device freezes because it's left out of memory, it has too many sessions to build in there, it's going to be left out of memory, then again it's bad, because you end up in a network down situation. But yes, unicast traffic does not hit the CPU of a device. of a network device unless it's destined layer 2 and layer 3 to that device. So only if let's say switch 1 has an IP address in that VLAN of .9 and PCA builds an IP packet with layer 2 source MAC of PCA, so source MAC of PCA and destination MAC of switch 1, and layer 3 is going to be a source of .100 PCA and destination of .9 switch 1. So only in this case, when PCA sends this packet in the network, switch 1 is going to accept the packet. And of course it's going to be destined to switch 1. But also if the layer 3 part is not destined to switch 1, is to .10, when switch 1 receives this packet because it finds in the destination MAC its own MAC address, it is going to punt that packet to the CPU, but then it's going to drop it because the address of .10 does not belong to the switch. So it's simple for any device in the world to accept an Ethernet frame. If it's broadcast, it's going to accept it. If it's multicast, it depends if it has joined a group. If it's unicast, as long as the destination MAC address matches my MAC address, I am going to accept the packet, even if at layer 3 is destined to me or not destined to me. So when I accept the packet, I'm going to process switch the packet to begin with. A question still from Piyush: how we identify microbursting? It's very easy. You have NetFlow. So as we did the other day, you have NetFlow in the network implemented, and one of the network devices is going to tell you that there's a huge amount of new flows per second created from the same source. So that's the easy way to identify that. Otherwise, more difficult to a firewall because it's going to have a huge amount of sessions which are built and teared down. So, but that's going to be pretty much a bit too late. So ideally, through NetFlow, you're going to be instantly notified that there's a device in the network which floods the network with a lot of flows. Aman, a question from Aman: so in real network, where would you deploy storm control? As I said, Aman, it depends on the platform because you got to make sure you don't drop control plane packets. But if you ask me, so it depends on the platform, first of all, on the line card of those platforms, and it depends on the security policy of the company you want to implement storm control. Because what you have to understand is the following: from the security point of view, we don't secure everything equally. It depends how critical that asset is. So like for example, if you have a network design with, you have the core network, the core. This is the core switch, let's say. So the core switch is it's a switch with redundancy with built-in redundant CPUs. And the core switch is connected via layer 3 links to distribution switches. So these are going to be distribution switches. Distribution 1, distribution 2. And let's suppose those are layer 3 links as I stated initially. So black is going to be a layer 3 link. And then distribution switches are connected to access switches via, let's say, layer 2 links. Let's suppose we don't run routed access mode, we run switched access mode. So for example, in this use case, if this PC in here gets infected, or maybe it's an attacker, and starts sending a huge amount of unicast traffic, then that traffic is going to go to both the layer 2 and layer 3 links. But if that PC starts sending a huge amount of unicast or multicast traffic, let's say not a unicast, if this PC starts sending a huge amount of broadcast traffic, that broadcast traffic is going to be contained in the layer 2 domain, because broadcast is not forwarded out of the VLAN. So if this guy sends a huge amount of broadcast traffic, then that broadcast traffic cannot be forwarded upstream to the core switch, because it never leaves the VLAN. If that device starts sending a huge amount of multicast traffic, and you don't have multicast enabled in your network, likewise it's going to be contained in that VLAN. If you have multicast in your network deployed, then multicast is going to be routed through the whole network. So as you can see, it already depends on the traffic type, unicast, multicast, broadcast. It also depends on if do you have multicast routing in your network or not enabled. But now in general, what you're going to do is, in general ID, you're going to go on the access switches, because it's better to prevent, to stop the bad thing from happening as close to the source. You're going to go to the access switches, and facing your access ports, you're going to put in there storm control on the access switches. And of course, you don't put random values. You got to make sure that user legitimate traffic is allowed. Like, as long as you know that you don't go and put in the whole network on access switches storm control which says, I don't know, 50 packets per second. You got to make sure that you meet each of the user's requirements. Maybe some user actively sends 50 megabits per second of unicast traffic in the network. Maybe other users send only 5 megabits per second, right? But in general, you're going to go on the access switches and implement multicast and broadcast storm control, because broadcast traffic should be very small. Broadcast should be only DHCP and ARP, and multicast should be null if you don't have multicast running in the network. So you go on the access switches and you're always going to implement multicast and broadcast rate limiting at very low values, because there's no way that the legitimate host is going to send huge amount of broadcast traffic or multicast if you don't have multicast enabled in your network. So by doing that at the access layer, you stop the bad thing from happening as close to the source as possible. But then of course, who can stop somebody from maliciously connecting a device? An attacker. Connecting a device, the attacker is going to physically plug itself to the core switch or to the distribution switch and perform a flood, a storm of unicast or broadcast or multicast. So to protect against that kind of attack, either have a physical security policy in place to make sure nobody gets access to the distribution of access switches physically, or on unconnected ports, you might have to also configure storm control as well. So it depends in there back and forth a lot. So Aman, I hope I answered the question. Also Piyush, I hope I answered the question with the microbursting. Question from Matthew. So Christian, how do you know what is storm from attacker or just heavy traffic load? Well, to understand if you have an attack or if it's regular network traffic, it means you need to have a baseline of the network functionality to begin with. Because everything which you put in the network, you need to have a baseline. You don't just come out of the blue and with a value of saying, I'm going to put in there a storm control value of 5 packets per second. If it's not good, I don't care. You should make sure that you don't drop legitimate user traffic, correct?